Greetings to you, listeners at home. You are welcome to Regina Pacis online class. My name is Patrick Obi. This is for mathematics, and we are here to solve a problem on integration. So this is the problem we want to solve. Given that y is equal to this, we are asked to find integral of y with respect to x from 0 to 1. So the solution. Now, first of all, we put in y to have this. And looking at this equation, you must first of all try to understand that integration has a lot of techniques. And sometimes for you to know the right technique to use, you will have to look at the question deeply. So looking at this equation, you can see that the numerator and the denominator can cancel out when you apply integration by algebraic substitution. Yeah, you can see that when you differentiate the numerator, it can cancel out the numerator. That is how you know that algebraic substitution, integration by algebraic substitution, can give you a solution to that integration given to you. So let us take a glance at what we have here. So we make the numerator, we say let u be equal to this. Now sometimes you might be confused, am I going to make the whole of the numerator u, or am I going to take a part of it? Now if you make the whole of the numerator u, you won't arrive at the answer. It's not going to give you something that will cancel out. So in this case, we are going to make just what's inside the bracket u, okay? So we call this u, okay? Now when we find the u, the x, we have this, alright? 3x squared plus 4x. So we can see that this, okay, the numerator is a factor of this. Now, when we factorize just 3 out of 8, we have this. Why did we factorize 3? Because we need to make this look like the numerator so that it can cancel out. So once we factorize 3, we have this. And here we make the x subject of the formula. When the x is the subject of the formula, we have this. So now we call this equation 3, equation 2, and this is equation 1. Now that we have this, we can see that x squared plus 4x is exactly what we have at the numerator. It is the right time to substitute equation 3 and equation 2 inside equation 1. So putting 2 and 3 in equation 1, we have this. So we can see that this can cancel out this. And once we cancel out that, we have this remaining. So the equation has compressed now to this. You can see that we only have u here, and that is the reason why we use integration by algebraic substitution. So we can now integrate this with respect to u. Once we integrate this with respect to u, once we integrate with respect to u, putting our limits, we have this, okay? So now we have done the integration, and we have the answer. But don't forget that these limits are in x, okay? This is x equal to 0 to x equal to 1. So we have to what? Finish up this by substituting u with the right value, okay? So once we remove u and put the value of u with respect to x, so we have this. And again, we are still going to apply our limits. So when we apply the limits, we have this, okay? Putting x equal to 1 gives us this. Putting x equal to 0 in this equation gives us this. So once we simplify this, we have 16 all over half, and this is this. Now once we do this, we have 7 all over half. And then it's now simpler to simplify. Once we bring this up, we have 7 times 2 over 1. And then we have 14. Then we simplify 4 and a half, 14 over 3. So the answer is 14 over 3, or 4 whole number 2 over 3. And that's the answer. So thank you for being part of the class. See you next time.